So we see questions this question 20 express in the form of r sine theta plus alpha. So means we change this pattern into this pattern. We have cos sine theta format, change it into the compound angle for sine format. So where our r here is a constant, is a number which is greater than 0, and the alpha here is an acute angle. So means that when we want to express this form into this form, we want to find out what is our r, what is our angle here. So the expressions means from this cos theta plus square root 2 sine theta, we will express equal. Let it become single trigo sine theta plus alpha. Okay, so this is what is the meaning from the question. Sila tunjukkan bentuk ini ke bentuk ini. So macam mana kita nak dapatkan bentuk ini? Maka kita kembang dulu. Kembang dulu kita punya compound angle ini. Expand our compound angle here, where sine A plus B, we use our compound angle, it will equals to sine A plus B, it will be sine A cos B plus cos A sine B. So we expand our compound angle sine A, where A is theta, cos B is alpha, plus so compound angle kalau plus they equal plus. Then cos A, where our A is theta, then B is alpha. So this is how we expand our compound angle. So remember, bracket here is not means that sine theta, sine alpha. It's not means that expand like that. So this bracket just want to make sure you know that this is our angle. For this side, we have two angles, theta plus alpha. So when we want to express these questions into this form, means we are going to find out what is our r, what is our alpha, because theta is the angle, their angle originally. So what is our r, what is our alpha? So we have two unknown to find. So I have to build up two equations. So by expanding our compound angle here, so our r still can expand in. You'll get r sine theta cos alpha, and then r cos theta sine alpha. So after I fully expand this r compound angle, we want to find out what is our r and what is our alpha. So from here, two unknown, we have to build up two equations. How to build these two equations? We compare back to its original form, cos theta. We compare the cos theta. So here we don't have cos theta, our cos theta is here. So coefficient of cos theta is 1. What is timing? The things time with cos theta here is 1. We cannot see. We didn't write the 1 here. So actually, so here it has a value 1. Coefficient of cos theta is 1. So means that after we compare this, our equation, we can get r sine alpha is 1. Compare the coefficient. Coefficient for cos theta is 1, so means r sine alpha is 1. And then we continue, we compare another terms here. Sine theta. We can see sine theta is here. Coefficient of it, the coefficient of sine theta is positive square root 2. So means r cos theta, r cos alpha is equal to square root 2. Comparison. So now we have two equations in order to find our two unknown here. So we want to find out what is our r and what is our alpha here. So by using these two equations, how we get r and get alpha, we can get our alphas very simple, divide. We use 1 divide by 2. Not every time is 1 divide by 2. Means I want to cancel the r by using tangent. If I I want tangent means 1 divided by 2. So you will get r sine alpha divided by r cos alpha. 1 over square root 2. So from here we can see when we use division, our r can be eliminated, and we use equation 1 divided by equation 2, I can get trigo tangent alpha. So I can get the alpha first. I can get the angle alpha first. So we shift our tangent to 1 over square root 2, we get 35.26. So this is how we eliminate r and get the constant alpha. So continue. After we eliminate r by using the concept of tangent, now we're going to find out what is our r. So we have to eliminate alpha. How we eliminate our angle alpha here, we use the concept identity, where sine square alpha plus cos square alpha will equals to 1. This is our identity. So when I want to get this sine square alpha plus cos square alpha, means that my equation need to be square, because now our equation here just sine alpha cos alpha. So I square these two equations, I add it together. So I will get sine square alpha plus cos square alpha. So when I square this equation, it will become r square sine square alpha plus square this equation number 2, it will become r square cos square alpha. So which is equal to 1 square is 1. Square root 2 square will be equal to 2. So from here we can factorize our r square, leaving sine square plus cos square. So this sine square plus cos square, we can eliminate it equals to 1. So therefore, we get r square equals to 3. So r equals to square root 3. So they want positive value only. So we don't express the negative square root 3 lah. So this is how we get our alpha and r. Okay, so once we get our r and get our alpha, means our expanded form here can be expressed in compound angle. Substitute our r and alpha. So therefore we can see here cos theta plus square root sine theta will be equals to r is square root 3. Then sine theta plus alpha, alpha is 35.26. So this is how we expand our expression in terms of these r things. R compound angle. So put in our r, put in our square root, put in our alpha. So from two trigo, I express it in single trigo. So the benefit expressed in r sine compound angle is for our part A. When we solving, it will be easier using single trigo compared to double trigo here. We have two trigo terms here. So we go for next questions. After we manage to express our double terms here, we have double trigo terms here into the single terms here. That's why the question asks us, please solve for this equation. And give your answer, give your solution, means give our angles between 0 and 360. Solving here in trigo, solving here means finding our angle. Yeah, just now I forget. I show you which part is important first. So of course expanded part here will be our basic, so that we can compare our equation. So this concept is how we compare these two equations come out. And we solve the simultaneous equation by solving it using tangent and identity. So this case is referring how we solve using identity and tangent to get to the answer. To get to the answer expression here. So therefore we continue here. So solve that. So our equation is cos theta plus square root 2 sine theta equals to srqt 3 over 2. So they give us an equation. So when we want to solving an equation, we must have a form of trigo angle value. Uh, we must have a form of trigo, then angle, then equals to a value. Then by using the fourth step, only we can solve this equation. So for this part, where we have double terms in trigo, we can use their expressions here, where it is equals to srqt sine theta plus 35.26. So when we use the expression there, actually we can get back to a single trigo. You can see we have single trigo angle. So in order to solve, means in order to find out what is the angle theta here, so we have to simplify until this format, trigo angle value. So for this question, we can simplify some more, where trigo is sine, angle is theta plus 35.26, and then square root 3 we move to the right hand side, we will get 1 over 2. So this is our trigo. This is the angle we're going to need to solve, and this is our value. So this question, this equation, they are ready in the format of solution. So the fourth step is, let us revise the step that we need in solution here. The fourth step here is, the first one will be our range. Then the second is talking about quadrant. Then the third one is finding about basic angle. And number four one is talking about rotation to find out the angle in the four quadrants there. So for the first part, range. Range means how far we want to solve our trigo here. They say our angles, our solution means our angles here, our angles here is must in between 0 and 360. So this is my step 1. This is my step 1. Theta is in between 0 and 360. But according to our questions here, our theta, our angle is not just theta. So our angle already plus 35.26. So theta plus 35.26, it will make our range become starting from 35.26 plus in our 35.26 plus in our 35.26. It will give us 395.26. So that will be our range. Means our answer later on we need to select between 35 some until 395. 395 something means start from quadrant 1 a bit until one round, after one round. 360 means one round already. Step 2, we determine our quadrant involved. Step 2 is determine our quadrant involved. How we determine the step 2 quadrant involved? We looking our equation here. Look at our value here. Sign value positive. All sign teacher crazy. So what is the terms here mean? Means their value. This is all where all trigonometry will give you positive value. This is the quadrant only sine give you positive value. This is a quadrant where tangent only give you positive value. This is a quadrant where cos only give you positive value. Now they say positive value for sine. So it will involve in quadrant 1 and quadrant 2. So sine, this one tangent only sine, this one cos only sine, means when our sine in quadrant 3 and 4, it will be negative. So this is our step 2, determine our quadrant involving. Then we go for step 3, basic angle. So our basic angle is we're going to shift it. So basic angle, step 3 here, I will write at the bottom of this equation. Our basic angle will be getting by shift our sine to the right hand side. So you bear in mind, if this one negative value, we don't take any more negative value because I want to find out what is a small angle here. So we didn't take any negative value here. The positive and negative value at here, value, you can see trigo angle value. the positive or negative value is for us to determine their quadient, our step 2. So after the positive value, negative value, we use it to know the quadient. Basic angle, we just need to shift the trigger to the value. Negative, we don't take. If this one got negative, we don't take the negative. So when I shift 1 over 2, we can get our basic angle is 30. Means inside this small angle here, this is 30. Here is 30. This small angle here in quadrant 1, here is 30. This is 30. And then here, quadrant 2, this side, this is 30. So that will be our basic angle. Lastly, then we only do our rotation. We do our rotation, 5 back. So our answer, when I shift, means here we will leave theta plus 35.26 at left hand side. So we start to do our rotation in quadrant 1. So quadrant 1 start from 30. So 30, is it involved in our range? No. So this 30 we cannot accept because our range is start from 35.26. So in quadrant 1, the first answer 30, not accept. Then we go for the opening angle to quadrant 2. So quadrant 2, when I want to go for quadrant 2, you see my mouse here. When I want to go for quadrant 2, here is 30, means this angle will be 180 minus 30. It is our range. It is inside our range because our range is start 35. Just now 30 not yet hit the minimum value. Our minimum value start 35. If you want to start the first angle 30, cannot. Minimum value cannot meet. So we go for second quadrant. Okay, they can. So 30, go to second quadrant. You want to get this second quadrant angle, it will be 180 minus 30. Then continue rotation. If I want to go for quadrant 3, we don't have any solution at here. I want to go for quadrant 4, also I don't have any solution at here. Then we revise after one round. After one round means I already have 360. So I can go for second round or not? Can. You can see my range here is up to 395. So when I go for second round, I just 360 plus one round plus back the first quadrant 30. After one round, 360, then plus the first quadrant. Again, we repeat the quadrant. 360 plus 30. Yes, this is 390. So we not yet exceed more than the maximum range we can go. So this is the both two solutions which is within our range here. Then finally, we simplify our data. So 180 minus 30, we minus 35. Move our 35 here to right hand side and minus 1 by 1. So we have two answers here. So this is how we do our solving. So the important things here is the first one. We use the expression from single trigger to answer our equation. That will be our first mark. Then basic angle is 1 mark. And then this rotation into the correct quadrant, 1 mark, and simplify back to data. So although these two steps, it doesn't give us marks, but we need it as our reference because our rotation start according to our range. And our gradient will be depends on the value that involving in our gradient. So these two steps we will write it, although it didn't have any marks because it help us to determine our angle in the correct quadrant and correct range, so that it only can lead us to the correct answer. So for part B, show the greatest value for this expression. So just now what can we get from part A is cos theta plus square root 2 sine theta. We already expressed it in single trigo, which is square root 3 sine and then theta plus 35.26. How we read their maximum value and minimum value? If we have this r sine theta plus alpha or r cos theta plus alpha, the maximum value will be square root 3. When we have this kind of pattern, r sine theta plus alpha, maximum value. When we're talking about value means the whole part maximum value is r, the minimum value is negative r. Because for this sine, you can see our sine graph, it is a sinusoidal graph. How the rotation, how the oscillation go, maximum value is 1, minimum value is negative 1. But if you already time with your r coefficient in front here, means our maximum value here will be r, minimum value here will be negative r. So this is how we get our maximum and minimum value by referring to our R double angle sine. So, but in this question, they give you a difficulty here that they already inverse the trigonometry. They become 1 per something. So when we have inverse function, maximum will become minimum, minimum will become maximum. So when you inverse it, our maximum, when we inverse our r sine theta plus alpha, our maximum will become negative r, our minimum will become r only. So that is the concept we need for answering these questions. So go back to this question. When they inverse our function here, we follow through. So 1 over cos theta plus square root 2 sine theta plus 5. This is our questions. So from this question, we substitute into the form of, we substitute r sine theta plus alpha. Okay, so we substitute our cos theta plus square root sine alpha into this term, into the r compound angle. So from here, we can read out our maximum or minimum value. So when we already inverse, means my maximum, the greatest means the maximum lah. The greatest value means they are finding for maximum value. So the greatest value here will be negative srqt for this part. The whole part here, the whole sinusoidal plus the maximum, the inverse. So negative, maximum become minimum, minimum become maximum. So maximum here will become negative square root 3. And we have a value at the back here plus 5. So this is our greatest value. But this answer is not in this format yet. So we have to change this third number into this. So it applies our topic 1 concept. How we change this third number. We will time with its conjugate. So for this conjugate, it will be square root 3 plus 5. Square root 3 plus 5. Supposedly it should be 5 minus 3. So the conjugate will be 5 plus 3. So I didn't write it in order, but we still can do it. So when we multiply it, we get 3 plus 5. At the bottom here, we get 3 minus times 3, negative 9, then plus 25. No, negative 3, negative 3, plus 25. So finally, we can see the denominator part is 22. And I write it as the question 5 plus 3 over 22. So from here will be our concept. use the R form, R sin data form. That will be our concept. Substitute inside here, and then we can see our maximum value this. Okay, so time with is conjugate, and we have our plus 5 applying inside plus 5. Finally, this is our answer. Okay, so saya ulang ya. Okay, kalau kita dapat A bentuk yang biasa macam ni lah. Sebelum dia jadi satu per ya, kita ulang daripada konsep yang asal. Kalau dia bagi kita bentuk macam ni je. Yang biasanya satu ni, satu sentence ni A sin ni. Kalau ikut sin punya graph, dia macam, dia ombak kan, dia macam ombak ni. Dia macam wave ni, maximum amplitude dia 1, minimum amplitude 1. So, bila dia darab depan dia, so kalau depan dia, so sini 1, maksimum 1, minimum negatif 1. Ini untuk sin saja, sin data saja. Kalau depan tu dah darab A, bermaksud amplitude graph tu akan darab A. So akan darab dengan A. So itu yang saya boleh dapat bila kita dapat A sin theta alpha, maximum amplitude ialah A. Sebab A darab 1 ni. Bahagian sin ni maksimum 1, minimum negatif 1. So bila dia darab dengan negatif 1, dia jadi negatif A lah. So itu yang untuk bahagian yang biasa ini dulu. Dan kita sambung. Bila dia inverse kan kita punya function. Dia satu per kan kita punya function. Maksudnya dia dah inverse. Okey, contohnya kenapa jadi macam tu ya. Contoh, sekarang saya ada nilai yang kecil 2 dengan satu nilai yang besar 3. Bila saya inverse function, dia punya hubungan akan terbalik. Ini asalnya minimum, sini asalnya maksimum. Bila saya inverse function, bahagian ni jadi bahagian lagi kecil daripada bahagian ni. Betul tak? 1/2, portion dia adalah lagi besar daripada 1/3 sebab ini 0.5, ini 0.3. So, bila kita ke function yang kita dah inverse ni, R1/R, jadi maksimum dengan minimum dia pun terbalik. So, bila kita nak cari yang maksimum, dia adalah sama dengan negatif R. Kita rujuk yang negatif, yang minimum value. Bila kita rujuk minimum, kita ambil yang maksimum. Sebab dia dah inverse, situasi maksimum jadi minimum terbalik dah. So, itulah sebab kita punya bahagian sini, asalnya, kalau tak ada satu per ni, asalnya sini adalah square root 3. Sebab amplitude sini R ni square root 3. R square root 3 darab 1 maksimum. Maksimum 1 kan? Square root 3 darab 1. Bila dah inverse, so saya kena ambil yang minimum lah. So, square root 3 darab negatif 1. So, inilah bahagian maximum value bila dah inverse. Kita akan rujuk kepada nilai yang minimum. Okay, so bila dia dah inverse tu maksudnya keadaan dah terbalik lah. Apa yang dia nak maksimum, kita rujuk nilai yang minimum. Apa yang dia nak minimum, kita ambil yang maksimum. yang maksimum. So that's mean by inverse lah, 1 per something. So value ni kita continue dan kita simplify kepada bentuk yang dia nak. So buatlah conjugate untuk cert number ni.